Hello and welcome to this week's episode of Automated in stunning color video, which is apparently how all people watch podcasts. I, of course, am your host, Stefan Seltz-Oxmacher, CEO and co-founder of Polymath Robotics. Sitting across from me is a bastard member of the house that Harkonnen is trying as hard as possible to hunt down, and we will succeed in taking them out.
Are you equating yourselves with the Harkonnens?
Yeah, the Harkonnens are pretty cool.
You need more suspensor belts.
Yes, I do. That should be our robot for the week. Unfortunately, we have a robot that is so close to something I just want to talk about anyway.
Awesome.
That it's not going to be suspensor belts, but yeah.
Yeah, I think I know what your Secret Santa gift is. It's just going to be suspenders.
I'll have to buy the ceiling harness from one of the many places in San Francisco that sells them.
That's from episode 1 or 2 with the gantry robot. Just tie to that and you'll be fine.
So this, of course, is Automated, our weekly podcast that we might actually have done 2 weeks in a row.
Don't cow your chickens till they go out on Spotify.
Where we talk about robotics, challenges in robotics, and we make up some along the way. We start the podcast off with a game where we have this lovely little app that chooses a random technology in a random market where we have to talk about a robot in. Usually that's supposed to be a bit of a joke robot. This one is something that I want to talk about anyway. So it's not going to be a real joke. I'm very excited.
Stefan has been building this up for me for the last 5 minutes pre-show, and I have no idea what it is. Yeah, so I want to know what it is.
Well, I mean, I just finished book 2 of the Bobaverse.
Excellent.
Excellent. This is a technology featured in it.
Okay.
Minorly.
All right.
For those of you who have not read the Bobaverse series, sleeper hit. I had not heard of it until someone joined our team who started pitching it. Fantastic sci-fi series. Guy's brain is into a computer, and then he's basically a robot AI, and he does a whole bunch of things across space, and it's like near-term sci-fi with a lot of 3D printing and robots.
You might want to skip over the book was published in 2016. You might want to skip over the first 3 chapters of America Turns into a Theocracy because that's just too close to home right now. But after that, it's great. It's
anyway.
Great series.
So this is our podcast. So first we'll play our game, and then we're going to talk about a subject this week. Ilya, what subject's that going to be? We're
going to talk about safety PR, I think.
Yep.
Which we've circled around this topic, so it might be a repeat for some of you, but we got some hot takes, I think.
Yeah. So with that, let's play a little game. And for those of you who are watching, I'll also wave around this box cutter that has been sitting on our podcast studio desk. Actually, we have 2 of them.
Since we put up the sound isolating foam, which again, I'll point out there's more on your side of the room.
Well, now I'm the one with the box cutters.
With all the box cutters.
How much trash you want to talk about my gains?
Yeah, you holding box cutters makes you less threatening somehow.
And with that, so I loaded up a little app, and it shows random technology and a market. And this, we got to remove this combo. We shouldn't do this because this is just more of a fun conversation.
All right.
The market is space exploration.
Okay.
And the technology is nanobots.
Okay.
Yeah.
Fair enough. Okay. Yeah. Pretty straightforward.
Yeah. So in the Bobaverse, there's lots of robots controlled by the Bobs, some of which are, robots that fly through space, some of which are little robots that crawl around the ship to maintain it. But a big common thread is kind of magic-y 3D printers that can print anything. So you mine an asteroid and you can then print your computer or whatever you need. In the second book, there's a set of baddies who reveal themselves to be using extensive nanobots that are like the size of ants and get wireless power.
You're like microbots, maybe. Ant size is too big to be nano. If you really want to be nano, you're really talking about 40, 50 molecules, really small.
I mean, given that we can't build a dog-sized ant that is super useful in the world on its own.
A dog-sized ant.
Yeah.
What do you
spot robots are in the let's see what we can do with them phase. In the mass useful phase. I think an ant-sized ant robot that was useful. I would round into nanobots.
No, because the nanomachine stuff, what's really fun about it is you're at a small enough scale that self-replication becomes more feasible.
Yeah.
If you could claim a lot of biology is sort of nanomachinery.
Yeah.
Like it's pretty close.
Yeah.
Right.
So I think like, even like mentioning that might get you excommunicated from the Catholic Church.
Wouldn't be the first time. But no, so there's a lot of research that kind of straddles the border between biology and I don't know, robotics right now on what is the smallest unit of sort of artificially created cell that can self-replicate.
Yeah.
And there's this funny kind of complexity dip where really, really straightforward, like, RNA sequences, we know how to make the conditions so that RNA self-assembles to some extent. Yeah. So that part's not simple, but it's reasonably well understood. And then like really big robots, we know how to put together motors. Yeah. But the chunk in the middle of like getting from RNA to functional cell, nobody's done anything there yet.
Yeah, I mean, like what I want is I want to send a server with an engine and some magic 3D printers and little resource gathering robots to Alpha Centauri. And I want it to mine enough stuff in Alpha Centauri and build enough additional robots so that when my human colonists get there, who can only accelerate for a long duration at 1.5, 2.5 G. When they get there, there's a city for them to show up and walk into. So I would like to build commercial gray goop. For those of you who don't know the term and aren't immediately afraid of the concept. Well, I envy you.
Gray goo. It's one of those apocalyptic kind of scenarios where somebody builds a nanotechnology that can disassemble whatever it encounters and build more of itself. And if it goes out of control, it just consumes everything in its path.
It's the entire world.
Earth, yeah.
Yeah.
I think we're not... I think that's a little bit ridiculous just from a power source standpoint of just like at some point they need to recharge somehow.
Yeah.
And logarithmic growth or exponential growth only makes sense in perfect conditions.
Yeah.
And even bacteria that follow that growth curve, there's bacteria that divide fast enough that they cover the earth in a week. But that's never happened because those perfect conditions don't exist. And it's the same thing, these nanomachines are going to hit something like, I don't know, seawater, which it's very hard to filter seawater to make more nanomachines. It's possible, but you have to filter gigatons to get a few grams. Like it's very it's very dilute.
They'll be able to stop spreading. Well, what if you just you had a gray goo continent, not a whole gray goo planet?
Yeah, exactly. But I mean, for space exploration, why that's promising is that the challenge of going far is to accelerate. The closer and closer you get up to light speed, the more and more energy you have to expend to get any faster. Yeah. And that energy becomes a lot cheaper if what you're accelerating is very small.
Yep.
So if you can get away with a tiny capsule, the size of a rice grain, we could accelerate that today with a powerful enough laser to another planet. Like that's well within our reach now. Yeah. But the problem that's missing is the rice grain actually being able to self-replicate and have enough intelligence to do anything meaningful.
So basically, if we built a nanomachine that was rice grain sized, we could
or a cluster,
and we found a known solid planet, not a Jovian, around Alpha Centauri, and we could shoot a laser at that grain or cluster of grains, to get there, and then they could build our Centaurian.
There's the minor problem of heat shielding for landing and all those things, but but
the terminal velocity of a grain of rice is not very high.
Is lower, So it is pretty fun, I think. Yeah.
None of the requisite technologies are even worth hand-waving about.
I mean, I think actually, again, we come back to power sources. Yeah. That's the real limit. There has been actually really cool research done on practical nanomachines. I think even University of Waterloo has a nanotechnology department on this. And but they're all externally powered. It's used pulsed lasers to make this thing move, or use external magnetic fields, or use whatever.
Yeah, which is, to be fair, what they do in Bob.
The
nanomachines.
Yeah, it's very cool.
Are powered by another piece of magic tech that is never explained.
Yeah, exactly.
Faster than light radar.
Yeah.
I mean, could you have a gram of uranium to power it?
Yeah, but
or a
just
module.
Just heat doesn't give you power. Yeah. Right? Just heat production. You need to convert that heat with a difference of temperature. So you still need radiators. You still need and thermodynamics, the smaller and smaller you get the more and more painful. Because when you're really, really small, even normal room temperature air is like soup.
Yeah.
So getting heat off of it is a huge deal.
Well, to change the problem for a second, let's say we solve the power problem, because
All
it sounds inconvenient, not fun.
And the heat problem.
Yeah. Inconvenient, not fun.
It doesn't instantly turn to 800 degrees and melt.
Yeah, don't worry about it.
All right.
No big deal. How would you go about building, actuators for movement for a robot the size of
I mean, you
because it's probably necessarily 3D printed because of how hard and complex all the small pieces are.
Oh yeah. I mean, I honestly think the way humanity will get there is through copying biology.
Yeah.
More than any actual physical assembly.
Yeah.
I think we reverse engineer how it's basically they're muscle cells. Even at ant scale, it's still a muscle cell.
Yeah.
How the muscle cells are anchored, how the joints work, right? Like if you're talking about ant scale, it's reasonably well understood how they work. It's reproducing them that's difficult.
Yeah.
When you look at cell sized, we can make artificial flagellum, for example, to make cells move around. Mm-hmm. But again, power source and
which is why the decrease in complexity happens.
Yeah.
Basically, like as you want something human sized or smaller, it gets harder and harder and harder and harder until it's a flagellum.
Yeah, until it's so small that you just throw.
And then you just zap power towards it.
At that point, it's chemistry. And chemistry is complicated, but it's not impossible.
So in some ways, an interesting thing about what's going on in humanoids is it's probably like the humanoid market is almost certainly lowering the minimal viable size of a complicated articulated robot. Where like
go on.
So if you think about like a car factory robot arm, like an ABBUR robot arm, those are 50 years old, and those are, let's say, nearly room sized.
Okay.
Or half of a room in terms
big,
of
table size.
Sure. Like a handful of very large joints that are very expensive.
Yeah.
And 10ish years ago, you had some robot arms that could do cool stuff that were like, the size of a desktop, but like it was a arm with like 9 DOF or 15 DOF or something, like not a lot.
Okay.
And a big part of the problem in humanoids that we've talked to death about is you need a lot of articulated robotics to the point where it seems super expensive, it seems super complex, and like what's the point for versus the use case. However, a thing that does seem to be happening is $500 million plus are being poured into solving those problems. So whether or not we get humanoids, who knows? I think we all have opinions about that.
Yeah.
But the massive investment in like, can we lower the usable size of a articulated robot thing? We're probably going from, we can build an arm as long as it doesn't move and it doesn't have a hand, to maybe we can build a crappy hand on an arm on a torso that twists. Maybe. And like, wouldn't it be cool if all the humanoid money meant that the minimum size of a pretty complicated robot went from like table sized to dog sized?
You're talking about just miniaturization.
Yeah.
Like there's more money going into it. Yeah.
Pushing miniaturization in a way that hasn't. And like ant-sized robots might still be 25 to 75 years away, and some series of hype trains and breakthroughs that like we can't even like make up on a podcast.
Yeah.
Outside of like, maybe we need to reverse engineer biology and grow ants that serve a function. But like the minimum size of a complicated robot might be like going down,
but that
by like 80% the next decade.
I think that's being driven.
And that could be phrased better. And
yeah.
There's probably some law that some like robotics PhD has come up with.
I think that's happening across the spectrum, though, right? Like sensors, for example, cameras were driven down in cost and size, largely because of mobile devices.
Yep.
And same for processing.
Yep. Lithium-ion
batteries were driven that way.
But like complicated actuators with feedback, haven't had the same.
Yeah.
And like that might be the research unlocked by this wave might enable that.
Yeah. It might be the next generation after that has benefits.
Yeah. And like much the same way that like we have the benefit of the $100 billion, $150 billion spent on self-driving cars to make it easy to automate weird mining equipment and weird ag equipment. Maybe some group 5-10 years from now will have the benefit of like working on the Tesla Optimus program to build automated dogs that can run through weird tunnels that sometimes go up and whatever, and for some reason wheels and treads aren't better.
I feel like I need that on a t-shirt.
Yeah.
Just automated dogs running through tunnels.
And stuff for some reason.
All right.
All right. So Grey Goo, probably not a business yet.
No.
But when it is, I'll ask for it to be taxpayer funded, because if we don't get the Grey Goo first, the Chinese might.
I mean, it's what I've always said. Make America gray again.
For all of our viewers, the camera angles have changed radically. And now we are somehow even less attractive than we were before. Go team.
Yeah.
Seeing clips of our first video thing was like, man, that is not a good angle for me. That does not show off my 6-pack in a way that makes people think I might have a 6-pack.
12 pack?
I think more like one of those like cheap little like kegs that aren't really kegs, but like Heineken sold for a while.
Kegerators.
Yeah. Yeah, so we've talked a lot about cruise, and I worry that we're talking it to death a little bit. But what I want to talk about this week was this concept of safety PR.
Okay.
And like it's funny. We gave a talk to a client of ours maybe like a year ago or so about this, and then we like resurfaced it for another thing, and we're like, should probably turn this into a blog post.
Yes.
So I wrote about or a third of a blog post, and then spent most of last week in my free time reading the Bob verse, because I read 2 whole books in the last 6 days. Just the best endorsement I could get for a book.
Which number of unfinished blog posts is this now?
Like so many. Yeah. Disproportionate number of, yeah.
Stefan's first job is CEO of Polymath. Stefan's second job is frustrated writer.
Like more like 14th job.
Yeah.
So safety is an interesting subject because it's something a lot of people care about, but I keep on being surprised by how many of those people don't have a really good insight into what it is. To the point where there's a really large company we've talked to before where I heard from behind the scenes that even though they have autonomous robots in the field, they have not yet determined internally what safe enough is.
Yeah. Yeah. And they've been working on it for a while.
Yeah.
Like this is not a new company.
Yeah. I think what's interesting about that is like, on one hand, there's like this platonic ideal of safety, which is like, I don't know, I feel warm and fuzzy. It is safe. I'm not hurt.
When I build a machine, it will never hurt anyone ever.
Yeah.
Under any condition.
I mean, like, there's like a layer. I don't think anyone would agree to that, but like, it's like, but like, kind of.
Yeah, exactly. It's like, oh yeah, okay, sure, if somebody jumps in front of it, but other than that,
the machine is safe. Well, what's safe mean? Safe.
Yeah, it doesn't hurt people.
Yeah.
Yeah.
So a long-term friend and friend of Polymath, Walter Stockwell, like has long defined for me at least, and the definition I go with for safety is that safety is the absence of unnecessary risk, which means there is risk. Which like that means there is risk in it. You could totally fall down the stairs when you get home and die. There is risk in walking up and down the stairs.
I don't know. I'm not going to buy a rover from you. You've admitted to the idea that failures can happen.
I have heard VCs say stuff as dumb as this.
I am going to buy not a robot, but a boat from these manufacturers called Titanic. They say it's unsinkable. That seems like a better bet.
A perfectly safe ship.
Exactly. Perfectly safe.
Former state senator Jeff Brandes in Florida, who wrote their autonomous vehicle law, once quipped to me that, we could end all traffic accidents, traffic fatalities in Florida. We just need to set the speed limit to 5 miles an hour.
And even that probably would work, but like, yeah.
Or we get 90% of them. We will save thousands of people a year. You know.
Exactly.
It's clearly a matter of trade-offs. And anyone who says otherwise is whatever. So then of course, what we care about mostly at Polymath is safety engineering. I guess, Ilya, how do you define that? So this is just the Stefan show.
Yeah. So breaking down what you had said, the absence of unacceptable risk.
Yeah.
So there's two parts to that. One
Yeah.
is how do you determine what is acceptable?
Yep.
And the other part is how do you determine that there's an absence of it? Right? So acceptable risk is you go through your design process
Yep.
and you understand what is the robot designed to operate in? How close is it to people? How dangerous is it? How fast does it go?
Yep.
What are all the scenarios in which it can go wrong? That's called HARA, hazard and risk assessment.
Mm-hmm.
And there's a bunch of other tools. That's one of them where you try to basically imagine every possible failure mode for this machine. That step, it should immediately, as soon as you hit that step, should immediately drive you to the idea of the simpler I can make the system, the better.
Yep.
Like by definition.
Yep.
Because the more complicated
Which is
your system
also a
is,
really hard concept for people to wrap their head around.
yeah.
Like I've heard people push back on this type of thought process. Be like, well, yeah, but like, wouldn't it be safer if you added one more sensor?
Yeah.
Like,
Wouldn't it be safer if
what's
there's
the
more
harm of adding this
Exactly.
extra complicated system to your complicated system?
Yeah, and to your other point, right? Like the safest robot is one that is turned off and is standing still, right? Like,
Well, it also can't follow. It's tied down, so
Right.
it can't fall over.
right. So like you have to balance that. But the simpler you can make your system to get started, and the more concretely you can define your use cases,
Mhm.
the easier of a time you'll have in your hazard and risk assessment. That's why for things like factories that have had a long history of automation, you have these very tightly defined, like here's a fence. You cannot pass the fence. Here's a laser safety fence. Here's a lockout system. Here's a room you can't enter as a human unless you flip the switch to turn the power off. That enables you to have chaos going on inside the room, and as long as the room itself is not breached, you're fine.
Yep.
So that's the first step, and that should be, 60, 70, 80% of your effort.
And I think what's interesting to call out about what you just described is it sounds kind of lame.
Thanks.
I know, but it does. It's like it's not waxing poetical about the big, interesting moral qualms of like the trolley problem.
Oh yeah. There's no discussion here of like when the car is driving and you see a toddler cross one way and a pregnant mother cross the other way, and like
who do
which
you run
one
over?
should you? That is irrelevant. To
Yeah,
the
that's
discussion
not
here.
engineering.
Yeah. That is. I'm purely talking about, is this car in a space where a person will cross at all? Yes. Doesn't matter. Like that is a risk we have to now start to plan.
Like, and I think like the a lot of people love the like trolley problem debates. A lot of people love the like, oh, what about this? What about that? I mean, I think another way to put it is a system that is engineered to be safe is safe with some denominator, and the numerator is one.
Yeah.
It will kill one person
per
some number of attempts.
Yeah. Attempts at killing people.
Yeah. For every mile it drives on the highway, for every so many miles on the highway, it will kill someone.
Yeah.
And like, frankly, I've also had discussed this with people who should know better and control budget and teams and priorities in relevant spaces who are unwilling to accept that premise.
Yeah.
And that means they're not engineering.
No, because
they're writing blog posts.
Well, you're not going to get there.
Yeah.
And that's part of the.
I mean, the Golden Gate Bridge, the numerator is one of chances it's going to collapse on a given day.
Yeah. Absolutely.
Yeah,
absolutely. Again, because otherwise you're talking about a lump of steel standing still on the ground.
Yeah,
like that's a zero chance. And then the second part is you can't possibly magically think of every condition you're going to get, no matter how intelligent you are, no matter how experienced you are. So the second phase is, as you build the system, you try to assess how often are we going to hit these scenarios, under what conditions do we fail, and then you go and you basically fuzz test. And this is why I find a lot of cybersecurity and actual safety overlap quite a bit, is a lot of the same concepts go in both, as you have intentional damage to the system during your testing to find out, okay, if I do disconnect this thing, what happens? If I can disconnect this and this, what happens? What level of safety am I trying to achieve? So to that point on the hazard and risk assessment, you say, okay, is it acceptable to me that this vehicle can, in this particular failure mode, hit a person 1 out of 1 million times? Or is it 1 out of 10 million times? Or 1 out of 100 million times? And all those barriers, the nice thing about the standards we follow is it says, if you're trying to target 1 out of 10 million to 100 million, here's the ways you can possibly achieve that. Because you can't possibly test 10 million
Which,
hours
again,
per revision of software.
All sounds pretty lame and complicated. And it's a bunch of like,
it's called
is safe
it's called engineering,
in
sir.
this situation. If these conditions are met, this likelihood of the time.
Yeah.
Or like, I'm 99% confident that I'm 99% safe. Is statements like that, which are deeply unsettling.
Yeah.
So like that's safety engineering. I often think of like this thing above that, which I call like safety marketing. Which like maybe you have a certification and you market the fact that you have that certification, and people who like know enough to recognize that that certification is meaningful then take this like basis of truth that you have this certification and say, okay, you guys are safe enough because of that.
Yeah.
Then there's this whole other thing that I call safety PR.
Yeah. Qantas never crashed.
Yeah. Was that used to? Did they used to say that?
No, I pulled out the first thing out of it.
Like, and safety PR is like vibes on is it safe?
Yeah.
And like why I think this is such a big thing is I once talked to a crisis comms firm around autonomous vehicle safety, and that team had done a bunch of stuff for Uber, and they put it to me bluntly. That the best number of people for us to kill with our autonomous vehicles is 0. The second best number is about 400 a year. Because once you're killing more than a person a day, no one really notices anymore. And it kind of all just fades out with the noise. And that when you kill someone, here's how you manage the story so that it goes away. Yeah. And here's how you like make the family okay with it. And here's how you build a framework for how to deal with that problem. That is not engineering. That is black magic, black hat weirdness of PR. And I think it's a useful time to call out right now that last year there was 2 different autonomous car programs, one of which killed 51 Americans while autonomy was on, who I won't name, but you can do some Googling and find out. The other of which, because people got tired of it and they had an accident where they mismanaged PR, got shut down, even though the accident where they mismanaged PR was a serious injury and not a death.
And wasn't even entirely caused by them.
Yeah, wasn't even entirely caused by them. Like, and they just mismanaged the PR part, the non-technical part, the hand-wavy, spoofy, non-real engineering part that has almost no connection to the platonic ideal of safety.
Yeah.
It's what got them shut down. And I think that's the real problem that robotics has with safety. It's not engineering, it's PR.
Yeah, because the entire safety design and there's many industries that take part in this. Think of aircraft or trains or cars. That's not a strange skill set.
Yep.
And it's very seriously studied. There's a lot of prior art, so that's very, very well defined. But as an engineer, I kind of like to just focus on that piece. Like, I can control this piece. Yeah. Like, this is well defined. There's rules. I know what to do.
And the challenge is like robotics is so hard that you suck up a bunch of smart engineers for multiple years, just spending their time trying to get the thing to kind of sort of work.
Yeah.
And it's such a massive accomplishment with that when they do that, like silly PR nonsense
isn't as important.
Yeah. How can it possibly be as important? These guys show up and they're clearly spoofers and they're clearly saying nothing of value. And they're hand waving and they don't know anything that they're talking about. How can they have anything to add when we are so smart we could build this?
Yeah. Yeah. And I think you had a good line, right? About if all you can do is spoofing. How did that go?
Yeah. So like spoofing is like business bullshitting, where to be successful in business, you have to be able to spoof. But if all you can do is spoof, you're not valuable at all.
And I think robotics is right now, especially in the investment environment, that's not entirely true yet.
Yep.
But over the long run, that always ends up being true.
Yep.
Like nobody can spoof forever. Mm-hmm. You can spoof for a very long time, but eventually you have to ship a product that works.
Yes, but as multiple people have confided to me, who are reporters who have covered that company that killed 51 people last year, it seems like a long time is pretty long.
Yeah. Oh, yeah.
To the point where these people
it can
are
be
like,
decades.
What did I do something bad by covering this company to help them get the platform that they have?
Yeah.
So yeah.
On that note, don't go into PR, girls and boys. Go into engineering instead.
Yeah. because everyone will be happy when you've sacrificed your nights and weekends for 8 years, and then you get in trouble because the PR people don't do a good job.
Yeah, that's right. It might be boring and detail oriented, but that's just engineering.
All right, Elliot, what are we going to talk about next week?
I don't know. Did we mention how we're doing on the podcast, by the way?
So thank you all so much for listening to this podcast.
Absolutely.
Like, really, holy crud. This is like, we're now like the number 3 robotics podcast.
Yeah. Metrics are wavy.
Yeah,
but,
super wavy. But, our producer said so. So I take that as gospel.
She's never lied once.
never in any context.
Exactly.
To anyone, not even as a joke.
Exactly.
Not even for PR.
Not even for PR.
Especially not being a marketing person. Especially not.
But thank you all so much for listening. Apparently people like listening to podcasts on YouTube, which news to me. But hey, thank you all.
Yeah, if you want to give a shout out, I would really, really appreciate thumbs up and subscribes on YouTube.
Smash that like and subscribe button.
I was going to try it. Stole the words right out of my mouth. No, but reviews on Spotify, reviews on YouTube, these are all great stuff. And
if there's other podcasts that you listen to, reach out to them and say, you guys are terrible, be more like Automated. Because we only win if our competitors, and I mean that in the most brutal way, feel bad about themselves.
Can you guess which one of us is the capitalist? But no, if we keep doing at this rate, we might have something fun planned for CS, and that'll be pretty great. So we'll keep you guys posted on that.
All right, thank you all so much for joining us this week.
See you next time.